Welcome to part 5 of our section 3.3 derivative rules. And here we are going to be focusing on the quotient rule, which is kind of like a brother rule to the product rule. Obviously, instead of a product, we have a quotient or a fraction. Now, quotients don't always have to look like fractions, and we'll see what a quotient can look like using a negative exponent later on with an example. But overall, when we have two things, those things might be monomials, one term, or larger polynomials. When they're being divided, what we do to find the derivative is we take what's in the denominator, v, times the derivative of the numerator, u, minus the numerator times the derivative of the denominator, all divided by the denominator squared. So I wrote it in two different ways. Instead of du dx and dv dx, I wrote u prime and v prime respectively. The fun way to say this, and I learned this from my favorite teacher back in high school, is low d high minus high d low over low squared. What does d mean? It means derivative. So it's high and low respectively are the numerator and denominator. So it goes low d high minus high d low over low squared. It's kind of fun. So here is what it looks like written out. Low, again, means the denominator, high means the numerator, and d means you take the derivative of that. Low d high minus high d low all over low squared. Let's look at an example using the quotient rule. In this example here, we clearly have a quotient, and we can label what u and v are here. So we'll say that we know that u is the numerator, it's x squared plus 1. And v is the denominator, it's 2x minus 3. Then we need to find u prime and v prime by finding their respective derivatives. The derivative of u is 2x. The derivative of v is just 2. I use the power rule for both of those. All right, now we want to find f prime. So to find f prime of x, I'm just looking right here. You can also think of the fun way to say if you like as well. You don't necessarily need the u's and the v's if that's the case. But I'm just going to look right here since that's how I've labeled. So I need v times u prime first. So v is 2x minus 3, and u prime is 2x. Then it's minus u times v prime. U is x squared plus 1, and v prime is 2. We're putting this all over low squared, or v squared. V is 2x minus 3. I'm just going to put that squared. All right, from here, students have made lots of errors at this point from when I've taught this a few times in the past. You do have to first do multiplication to clean this up. So to do multiplication to clean it up, we're going to distribute the 2x through here. So we'll have 4x squared minus 6x. Then minus, we are going to do multiplication distribution here as well, but I still need parentheses because of this minus sign. Because if we did not put the parentheses, we'd only have minus the first term, and it's minus all of what's in here. So we'll have 2x squared plus 2 inside the parentheses there after doing that distribution. And it's still all over low squared, which I'm just going to put quotes there so I don't feel like rewriting it. And that's totally fine. Now when we keep going algebraically, I'm going to distribute the minus sign through. We'll have minus 2x squared and minus 2 all over the same denominator, lazy math. Then I can combine some like terms. We'll have 2x squared minus 6x minus 2 all over the same thing. Then I want to see if I can clean up the numerator at all. And what I can do is I can factor out a 2. We'll see if that helps at all. So we'll factor out a 2 and we'll be left with x squared minus 3x minus 1. All over, I'll write it out, 2x minus 3 quantity squared. Now from here, I want to see if I can factor anything more. Like, can I factor what's inside this parentheses here? Are there two numbers that multiply to -1 that add to -3? No, I can't go any further. And so this is the most cleaned up we are able to get. And so this is fine. This would have been fine too, obviously without the quotes. Um, but I wanted to factor the 2 out to see if I could go any further with factoring, and we can't. So this is a proper way to write our final answer. A lot of calculus, if you haven't realized already, is algebra cleanup. It's being good at distributing the negative signs properly, multiplying properly, especially with exponents, combining like terms, understanding how to factor, and understanding how to cancel. Let's take a look at a few other examples of the quotient rule. In this first example here, at a first look at it, it does look like we have a product, and technically we do. However, because it's raised to the negative first, there's going to be some issues there. What raising something to the negative first means is that it belongs in the denominator. And we've discussed this before. So the x squared minus 1 stays up top. It's raised to the first power. This x squared plus 1 belongs in the denominator, raised to the positive first power. So I've not done any calculus yet because I've not done dy dx or y prime. I have only rearranged what this is algebraically. And so this is an example of how something might not initially look like a fraction, but it still is technically a fraction or a quotient. A negative exponent means that it goes in the denominator. All right, so now that we have our quotient written out, I'm going to use the fun way to use the quotient rule, and that is low d high minus high d low over low squared. So here is our fun way of the quotient rule written out. I'm going to use this instead of the u's and the v's. Whatever way works for you, that's why I give you multiple ways to use it. So let's do this the fun way. I'll call this dy dx, since now we're doing calculus, and I'm denoting that I'm about to take the derivative with dy dx. So we have low d high. So low is the denominator, and d high is the derivative of the numerator. So the low we'll write first, low, times d high. The derivative of the numerator is just 2x. Then we want to do minus high d low. High is the numerator. D low is the derivative of the denominator, which again is 2x. I'm using the power rule in both cases when finding the derivative of the numerator and the denominator, the high and the low. The minus 1 and plus 1 parts are the constants, and therefore they do not have a place in the derivative. Their derivative is 0. All right, now this is all over low squared. Low is the denominator, and then it gets squared. Normally, you do not have to worry about multiplying the denominator out. I'm not going to do x squared times plus 1 times x squared plus 1 and write it all out. We'll just see what happens writing it like this. Let's clean up the numerator a bit. In cleaning up, we're going to distribute. So we're done with the calculus at this point. We did all the calculus. Now this is algebra cleanup. So I don't need parentheses there. We'll have 2x cubed plus 2x. Then minus, here's where I do need the parentheses because we're subtracting more than one term. Then we'll have 2x cubed minus 2x all over the same thing. I'll just use quotes again. When we keep going here, we'll distribute the minus sign through. So we'll have 2x cubed plus 2x minus 2x cubed plus 2x all over the denominator. The cube terms end up canceling out, and the two 2x's combine to 4x. So 4x is our numerator, all over our denominator, which is x squared plus 1 quantity squared, and that's what our derivative ends up being. We cannot cancel anything there. This one is a great problem using the quotient rule that also uses a ton of algebra. So here, what I'm going to do first is identify, I love the fun way of doing this, so we're going to do the low d high minus high d low over low squared method in this example as well. Let's get right to the point. F prime, we have to use the quotient rule. So low d high, low is our denominator. D high is the derivative of our numerator. Using the power rule and the sum rule, we're going to take the derivative of each term. So the derivative of x squared is 2x, plus the derivative of 3x is 3, minus high the numerator, times d low. D low is the derivative of the denominator. The derivative of the denominator is the derivative of each term using the sum rule. The derivative of 1x is just 1, plus the derivative of 4 is 0, all over low squared. Then in our next step, we want to multiply out using algebra. So we're done with calculus. We've done all the calculus we needed to do. So we're going to distribute in this next step. So we'll distribute our x through first, and then we'll distribute the 4 through. So we'll have 2x squared plus 3x. Then distributing our 4, we'll get plus 8x plus 12 minus, distributing through by a 1 doesn't do anything, so we just have x squared plus 3x. And then again, we're all over low squared. So now we can combine some like terms as well. Well, actually, let's distribute the minus sign through. So we'll have 2x squared, I'll add the 3x and the 8x, and we'll have minus x squared minus 3x all over our denominator. Then we can combine some like terms. The quadratic terms simplify down to just a 1x squared. Our linear terms become 8x, and our constant is a 12, all over our denominator. Now in the numerator, we have a quadratic trinomial, which can that be simplified? Meaning, can it be factored? Are there two numbers that multiply to 12 that add up to 8? You betcha. So that can be simplified into x plus 6, x plus 2, all over x plus 4 quantity squared. Now, can we simplify any of these factors? No. None are exactly the same. If one of these factors up here ended up being x plus 4, we could cancel one of the x plus 4s from the numerator and the denominator. But in this case, we can't. Now, this looks more complicated writing it this way. It's important because a lot of times in calculus, we'll see shortly, we want to either set the numerator or the denominator to 0 because we care about when our derivative is 0, when we have a horizontal tangent, or we also care about when our derivative is undefined, if the denominator can equal 0. So factoring and the algebraic side of simplification is super important for those reasons. In our final example here, I want you to see that we definitely have, again, we have a quotient as our function, but here we do not need to use the quotient rule. Now I want you to think about why that is. Pause the video and see if you can figure out how to write this without it being a fraction anymore. If you did in fact figure it out, that is pretty impressive. And if you didn't, that's okay, but let's take a look at f of x. We do not need to deal with this using the quotient rule because it would take unnecessary time. When we have just a monomial in the denominator, a single term, we can rewrite this as both of our terms in the numerator over that same denominator, right? A common denominator. And if you note here, once we've done this, we can actually cancel top to bottom. 3 over 2 can't cancel, but one of the x's certainly can, so that becomes x squared. Then these x's can cancel, and this becomes 2 over 1, which is just 2. So our f of x can really just be written as 3 halves x squared, or 3x squared over 2, same thing, minus 2. And that's super easy now to find f prime. I'll leave that as an exercise. You can just use the power rule and the constant rule. All right, I hope you understood the quotient rule, and always look for, even if you see a fraction, you don't always have to use the quotient rule. If your denominator is a monomial, meaning one term, you might get lucky enough to where they can cancel out from the numerator and you're not left with a quotient anymore.